Well, welcome back to another exciting night. Our topic here is called square root arithmetic. So you're all familiar with the square root symbol, and arithmetic means we're going to add and subtract these square roots. Now some of this might look familiar, perhaps you did it back in Algebra 1, and if it doesn't, that's okay too. Just remember to jot all the examples down. So let's dive into our three main square root properties. So we do want you to copy this into your notebook, nice and neat, so pause it if you need to, and we'll talk it through. It says for any two positive real numbers a and b, the following are true. So radical a times radical b is really equal to radical a times b. So now underneath that, let's put an example. If I said radical 5 times radical 2, that is equivalent to radical 10. You are allowed to multiply what's underneath the radical, and you just keep it in the radical. B. Radical a divided by radical b is the same thing as one large radical of a divided by b. So again, let's get an example to go with that problem. If I said the square root of, let's say, 5 over 4, the first thing I'm going to do is rewrite that taking the square root of each number separately. That's the square root of 5 divided by the square root of 4. Now I'd ask myself, do I know one of those answers? Well, hopefully you're saying yes. We should know the square root of 4 is 2. Now I don't know the square root of 5, so that's going to stay under the radical. And lastly, example 3. If radical a plus radical b are not the same numbers, you cannot add them together. Alright, so you cannot add two radicals if they're not the same. And that's our adding rule. I cannot add radical 5 plus radical 2. Alright, all I would say is simply that is done. I cannot add those together. Now, let me switch that real quick. If I said radical 5 plus radical 5, well then I could say, okay, because these are alike, I have two radical 5s. Example 1. The first square root property allows us to rewrite the square root expression in simplest radical form by factoring out any rational factors of the square root. Write each following in simplest radical form. So basically, I want you to put exercise 1 and say simplest radical form. Now, we're always looking for a number that is a perfect square and one that's not. So let's run through those perfect squares again. You probably know most of them. I would say 1 is the first one, 1 times 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. You should be listing these out as well. 8 times 8 is, 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. 12 times 12, 144. And I would say you should probably know up to at least 12. Now, the idea is we are looking for, we want one, I'm going to use PS for perfect square, and one non-perfect square. Alright, that's my goal. I need a perfect square and not a perfect square. So let's take example A, radical 48. Alright, I need one perfect square and one not perfect square that goes into those. Now, in general, I want to pick the biggest perfect square I can find. Now, if it's 48, certainly it's not going to be anything bigger than it, so all of those are out. 36 doesn't go in there, 25 doesn't go in there, but wait, I believe 16 does. So I'm going to say radical 48 is equal to, property 1 says you can split it up, radical 16 times radical 3. And the reason I can split it is because 3 times 16 is 48. Now you're just saying to yourself, which one of those do I know? Well, the square root of 16 is the number 4, so it comes outside, and we're going to leave the radical 3. So my final answer is 4 radical 3. Let's try another one. Question B was radical 200, or the square root of 200. Okay, and I'm looking for two numbers that multiply. That was property 1, two numbers that multiply to 200. One of them has to be from my perfect square list. Hopefully you've guessed that one. That one's pretty nice. I'm going to go with 102. Because 100 times 2 is 200. Now again, you say to yourself, which one do I know? Well, the square root of 100 is 10, so that comes outside. I don't know the square root of 2, so I leave it. Now, If you have to break this down again, if you didn't pick the biggest one, that could be an option, so be very careful. C, we had 5 square root 18. 5 square root of 18. Okay, now notice this 5's out front. We're just going to keep it out front, because if I read this, it says 5 times. When things are next to each other in math, we multiply. So I'm going to say this is 5 times, and what two numbers can I break 18 down to? Now remember, they have to be from our perfect square list. If you're taking a peek at them, hopefully you're saying 9 and 2. Sounds good to me. So I'm going to go with 9, and I'm going to go with 2. Now remember, we're multiplying all those. So I'm going to keep my 5 outside times. I know this 9 turns into a 3 times. I don't know the square root of 2. So remember, we're multiplying, so my final answer is going to be 15 radical 2. And that's really 15 times radical 2. All right, I think we had one last one. Let me scroll back up and peek what it was. Radical 72 over 2. Okay, so this time I'm going to ask myself, what breaks down to 72? Now, maybe you're thinking, let's see, what numbers do I know? 9 times 8? Now we can use that, but watch what happens. Radical 9 times radical 8, and again, that's because 9 times 8 is 72, and I'm going to keep that all over my 2. Now ask yourself, which one do you know? Of course, you know the square root of 9 is 3, so I'm going to say that's 3 times radical 8 divided by 2. Now, can I divide the 2 and the 8? Well, hopefully you're saying, heck no, they're not in the same spots. The 2 is outside the radical, and the 8 is inside the radical. But here's the bear trap on this one. Is radical 8 all the way broken down? No, so you've got to do it again. So we've got to keep going till we're completely simplified. All right, so what numbers multiply to 8? Well, I'm going to say 4 times 2. And remember, we're multiplying all those over the number 2. All right, so if I keep cleaning it up, I know I have a 3 times, the square root of 4 is 2, times radical 2 divided by 2. So that leaves me with 6 radical 2 divided by 2. Now I can clean these guys up because they are outside. So 6 divided by 2 gives me 3 radical 2. And there you have it. So if I went too fast at any point, make sure you pause it, rewind it, and try it again. Exercise 3. Here's a common multiple choice question. Which of the following is the product of this quantity times this quantity? Now, certainly you can't do that in your head. You've got to show work on these multiple choice, and I think some of us are learning that the hard way. Don't just guess. You've got to show work on multiple choice. So let's rewrite that problem out. Radical 12 minus 4 times radical 3 plus 3. All right, so hopefully your gut says when you see two things like that in the parentheses, we like to FOIL. So I'm just going to take my time and FOIL. My first, okay, I basically have radical 12 times radical 3, and property 1 said you can multiply those. So that gets me radical 36. My outsides, notice this guy is inside a radical and this guy's outside. You cannot put them together. So we're just going to say that's 3 times radical 12. That's all we can do. My insides, the 4 is not in a radical, but the 3 is, so they don't go together, so just minus 4 radical 3. And then lastly, my last are going to get me a minus 12. Now, we did the hard part. Now we just have to clean it up. And you just take your time at each set of, or each term, and you should be in good shape. 36, do I have to break it down, or should I know that answer? Well, I know the square root of 36 is 6. Okay, plus, now 12, I don't know, but I know I can break it down, so I'm going to say that's 3 times. What two numbers can we use for 12? Do you think 6 and 2 work? Well, remember, they have to be from our perfect square list, and 6 and 2 are not on there. I'm going to have to go with 4 times 3. Okay, then I have my minus 4. Can I break radical 3 down, or is it simplified? Pretty sure it's simplified. So I'm just going to leave it. And then my minus 12. All right, now just carefully keep it nice and neat and clean up. This is really 3 times. This turns into a 2 minus 4 radical 3 minus 12. So I really have 6 plus, that gets me 6 radical 3 minus 4 radical 3 minus 12. And lastly, I'm just going to put my like terms together. I'm going to box in my 6 and my minus 12, and I know 6 minus 12 is a negative 6. And look at these terms. They have like radicals, so I can add the outsides. 6 radical 3 minus 4 radical 3 gets me a positive 2 radical 3. And now that this is completely simplified, I'm just going to look for that choice. I have a negative 6 and a positive 2 radical 3. And they could be in the opposite order. Here's the negative 6 and the positive 2 radical 3. So I would go with choice 1. So again, I just want to stress, even though that was multiple choice, it requires a lot of work. Keep that in mind on our tests. Exercise 3. Which of the following is equivalent to this quantity, radical 8 minus 2 squared? So hopefully the first thing you're saying to yourself is, what does squared mean? Well, squared means you have that written down twice. So make sure you rewrite it twice. All right. At this point, why don't you pause it, do your FOIL, and then play it back and see if we've got the same 4 numbers. So just pause it, FOIL it out, and see what you get. Did you get what I got? I've got radical 8 times radical 8, inside and inside, so that's 64. This is outside and this one's inside. This one's outside and this one's inside, and then the plus 4. Watch your signs. All right, so do you know the square root is 64, or do you have to break it down? Well, I know 8 times 8 is 64, so that turns into an 8. Now look, I have like terms. They both have radical 8s. So I would say I have negative 4 radical 8. I just add those outsides. And then I have this nice plus 4. All right, so I can add my 8 and 4, which gets me 12 minus 4 radical 8. Now, is this simplified? Hopefully you're saying, no, it's not. This radical 8 can still be broken down. So let's keep chugging. I'm going to say this is minus 4 times what 2 numbers multiply to radical 8? Well, I'm going to go with 4 times 2. And then lastly, I've got 12 minus 4. I know the square root of 4 is 2. Notice I'm multiplying, times radical 2, which leads me to 12 minus 8 radical 2. And hopefully you got the same thing there. I'll just scroll back up. What do we say? 12 minus 8 radical 2, and we'll go with choice 2. Again, a lot of work to get to that answer. All right, generally speaking, it is only possible to combine square root expressions when they contain the same radicand, the number under the square root. When 2 square root expressions do not contain the same radicand, then summing them is equivalent to combining like terms. So what do I need in your notebook there? Basically, you can only add when you have the same number under the square root. Okay, it is only possible to combine expressions when you have the same number under the square root. So in exercise 4, we're going to express, notice it says in simplest radical form. If it's not simplified, you won't get full credit. So let's start with example A. I cannot just add these together because they are not like. The number under the square root is not the same. So you have to simplify each radical. So let's start with 27. Remember, I'm looking for 2 numbers that multiply to radical 27. My guess is you figured them out already, and I'm going to go with 9 times 3. Now, I rewrote our perfect squares off to the side there. Remember, you got to pick one of those. Then we have a plus sign, and I need to do the same thing for 75. I'm only looking for 2 numbers that multiply to 75. Now, sometimes when I end in 5s there, I try to think about money. I would say 25 cents times 3, or 25 times 3. Now I'll just go through and simplify. I know the square root of 9 is 3, radical 3, plus the square root of 25 is 5, radical 3. Now notice, is the number under the square root the same? Radical 3 and radical 3. It is. So now we simply just add the outside terms. That gets me a total of 8, radical 3. All right, let's attack the next one. we've got radical 50 plus 7 radical 8 plus 2/3 radical 16. All right, I just rewrote it down at the bottom here. Again, why don't you pause it and just see if you can break the radicals up the same as I do. Remember, one number has to be a perfect square and the other doesn't. Well, I got mine. Hopefully you've got the same thing. I've got 25 times 2 makes 50, 4 times 2 makes 8, and 81 times 2 makes 162. Now again, just watch how neat and we keep things here. I know the square root of 25 is 5 times my radical 2, plus I have a 7. Square root of 4 is 2, now so times 2, radical 2. Then there's a plus sign, keep my 2/3. The square root of 81 is times 9 times radical 2. So again, I'm just going to keep cleaning up. I've got 5 radical 2 plus 14 radical 2 plus 2/3 times 9. Picture this. I'm going to put that 9 over a 1. So on top I have 18. On the bottom I have 3. And 18 divided by 3 is 6 radical 2. Now, can you actually add these together? Well, are the numbers under the radical the same? Yes. So 5 plus 14 plus 6 gets me 25 radical 2. And that's my final answer because 2 is as simplified as I can make it. Exercise 5. Consider the right triangle shown below that has lengths of radical 18 and radical 32. Determine the length of the triangle's hypotenuse in simplest radical form. Okay, start looking for that term. Radical form means you have to have a radical in your answer. So I'm going to call this x. Now hopefully you're thinking Pythagorean theorem, which is a squared plus b squared equals c squared. And the only thing you have to remember was c squared has to be the hypotenuse. Alright, so I'm going to call this side a, this side b, and this side x is my c. So when I write this, I'm going to sub in with parentheses the square root of 18 squared plus the square root of 32 squared equals x squared. And I'm just going to carry my work down here. When I square and square root, remember those undo each other and I just get 18. The square and square root undo each other and I get 32 equals x squared. 18 plus 32 gets me 50 equals x squared. And now to get rid of a square, remember you take the square root of both sides. So I get x equals the square root of 50. Now if I stop there, I'm only going to get 1 out of the 2 points because it says in simplest radical form. So simplify your radical. What times what gets you 50? 25 times 2. And the square root of 25 is 5. So x equals 5 radical 2. Part B says determine the perimeter of the triangle in simplest radical form. Well, remember from your geometry days, the word perimeter means to add all the sides. So let's see, my 3 sides are radical 18 plus radical 32 plus 5 radical 2. All right, so can I add these the way they are, or do I have to break them down? Well, remember, we need to break them down so we have like radicals. 18, hopefully you're thinking 9 times 2. 32, I'm going 16 times 2. And this one already is simplified, so I'm just going to leave it. This becomes 3 radical 2 plus 4 radical 2 plus 5 radical 2 for a grand total, let's see, I think that's 12 radical 2. Okay, so remember, you're just adding the outside terms when you add. Exercise 6. This one's a bear. Which of the following would be equivalent to that quantity squared? Well, remember, when I see that, I need to write it twice. So I've got 2 minus radical 3 times 2 plus radical 3. So it's really all of that times itself. How crazy is this? 2 minus radical 3 times 2 plus radical 3. Alright, so we've got some mad foiling going on here. Let's just start with the first one. I'm going to kind of break it up here. Let's just start on this side, and let's go ahead and FOIL that out. So when I FOIL that out, I'm going to get 4 plus 2 radical 3 minus 2 radical 3 minus radical 9. Would you agree with that? 4 plus 2 radical 3 minus 2 radical 3 minus 9. Now, I don't have to FOIL this one because I know it's going to be the same thing. I'm going to clean this up, and I'm going to say I get 4, a positive 2 radical 3, and a minus 2 radical 3. Those are conjugates. They just cancel. So 4 minus radical 9, well, wait a minute. I know what radical 9 is. Radical 9 is just 3. All of that really just turned into 4 minus 3, or 1. Now remember, because I multiplied by the same thing, I would get the same answer. So I'm really just taking all of that, and this is also going to be 4 minus 3, which is 1. And 1 times 1 is just 1. What a crazy way to get the answer of 1. Alright, our last problem for the night is 3 radical 6 plus 4 radical 18. Now remember, I can't add unless the number under the radical is the same. So can I break radical 6 down? Can you come up with any numbers that multiply to 6? Well, I know someone's going to try to tell me 2 times 3, but are either of those perfect squares? Do any of our perfect squares go into 6? No, so that one actually is simplified. I just get 3 radical 6. Now 18 I can break down as 9 and 2. Alright, so remember, these are next to each other. They get multiplied. I really have 4 times 3 radical 2. So I end up with 3 radical 6 plus 12 radical 2. Now, can you actually add those two together? Well, remember, if they're not the same under the radical, you just can't. As long as they're simplified, sometimes you're just done and you have this crazy long answer. And that's okay too. Alright, but just make sure your radicals are simplified. Well, hopefully you're feeling pretty confident, and we'll see you tomorrow.